had the cousin over, and we were playing Super Mario Brothers, Super Mario Brothers Deluxe to be exact, on the Switch. So we played that for, I don't know, 3 or 4 hours, and then switched over and played little Mario Kart for another couple of hours. Then Sunday, my wife and I got home and started playing some more Mario Kart. So my daughters came over and they joined us. So we played a little Mario Kart. Yeah, we were playing with the settings on our Mario Kart to make it where when you go through the boxes and you always get like, a mushroom or a turtle shell or something. We changed that to where the only thing you got were like the bullet things that shoot you up from last place to first. So every box had bullets or rockets or whatever. I think they're bullets because they come out of those cannons. They're like, so every box you hit on the track had those, and it was just chaos. It'd be like 6 of them flying past you when you weren't a bullet, and so you had to stay out of the middle of the track. You get ran over by bullet after bullet after bullet after bullet. It was crazy. It was fun though. We had a good time. Class won't be real long today. We don't have anything new to cover. Just going to show you what we got this week. All right, so this week we just have a test over everything we've done since January, basically. Units. We did 2.6 and 2.7 in early January, but we're testing 2.8 to 3.3 right here. So you click on that, you've got the link to go to formative, and I've included a study guide. Right here is a study guide. You can download that, or you can just, you can print it if you want to, work it on paper. But I've also included an answer key. So when you work the study guide and you're like, I don't know if I got the right answer, if I did that right, you can also check out the study guide answer keys. Let's look at the study guide real quick. I'll just hit a couple of things on here. Since you do have the answer key, you can go back to. Starts out with simplifying these exponents. And your final answer should have only positive exponents. That's important because like in this problem, there's an x to the -1. Here's a y to the -3. Z to -3. Anytime, if you remember, if I have an exponent that is a negative, x to the -2, that's the same thing as 1 over x to the +2. Right? That's how you make an exponent positive, is to move it down to the denominator. If it's in the denominator, you just move it up into the numerator. Either way, that's how you make it a positive. So this really is the same thing as 1 on top because there's nothing up there. If I move this to the bottom, I'll flip this to 1 over 4x to the 4th times another x, because that's x to the 1st. I can put a little 1 there, but it's times another x. So that's rewriting that. Now I've got to simplify this. That's not simplified. I've got 2 x's. This would simplify to x squared over y to the 3rd times x to the 3rd y squared. See, rewriting that as a positive exponent, I move it to the denominator. Now I've got to do this and simplify it because I got 2 x's and 2 y's. I need to simplify that where I've only got, 1 term instead of 2 terms being multiplied. But I just want to remind you about how to do that. This is what we're used to doing, simplifying in simplest radical form. We've been doing that the last few assignments. This is a cubed root of 48. Remember, it always helps to have your notes. Have your notes. These are the notes we took a few weeks ago. They have perfect squares, cubes, and fourths. I would also point out, since we're talking about our Google Classroom, if you go back a couple of weeks, there's a list of perfect squares, cubes, and fourths right here in week 26. If you click on that, here is x squared, x to the 3rd, x to the 4th, all the way up to x to the 5th, all the way down from 1 to 25. So if you want to know the 4th root of 6,561 is 9, because 9 times 9 times 9 times 9, 6,561. So here's a bigger chart than the notes that I had. This goes all the way to the number 25. I just did the number 10 on my paper. So if you want a bigger one than this, it's right there in Google Classroom. But yeah, simplify these things. Remember, a 3rd root. 48 is not a 3rd root, right? But we can rewrite that as the third root, since 8 is 8 times 6, which is also the same thing as the third root of 8 times the third root of 6. And the third root of 8 is 2. So this is 2 third roots of 6. There's the answer on that one. 2 third roots of 6. We just rewrote it and simplified it. Simplest radical form. Cube root of 6 is as simple as it gets. Because there's no cube roots we can take out of it other than 1, and that doesn't change anything. So there's that. Let's see what else our study guide has. Convert the following from exponential to radical, or radical to exponential. Whichever it is, make it the other one. These are exponential, make them radicals. These are radicals, make them exponential. Like, one thing I'll point out, this is 50 to the 1/2 power. So that means square root of 50. On these, you do not have to simplify. You can if you want to, but it just says convert. This does not say write in its simplest form. So this is an acceptable answer for 50 to the 1/2 power. That's the same thing as the square root of 50. All right, so on these, read the directions for each problem. If it says simplify, this is not a final answer, because this would simplify to 5 square roots of 2. That would be the simplest answer. But I would take either one of those answers, since it does not tell us we have to simplify. This is find the inverse of each function. Remember how to do that? First, you change to y equals, right? That's the first step. And then swap x and y. And then solve for y. Remember the 3 steps there. So we make that y equals the square root of x plus 3. Then make it x equals the square root of y plus 3. And then you need to solve it for y. So your final equation would be y equals something. You'd solve that for y. You move the 3 over, then you got to square it to get rid of the square root. You got to square it. So you'll end up with something over here squared. Verify. Oh, that's a big word. It means a lot in math. Verify whether the pair of functions are in inverses of each other. Show all work. To verify, that means we've got to look at f of g of x. We will substitute this into there, which would be negative 16 plus 4x plus 16 over 4. And then we would simplify that. See, we took out this x right here, and we substituted in g of x. Because that's what it said to do. It said take g of x and substitute it in for the x in f of x. When we simplify that, if it equals x, which this would, negative 16 plus 16 cancel each other out. 4x divided by 4 is just x. That's a good indication that it's going to be an inverse, because if it equals x, and then if that also equals x, which we would have to substitute that in and simplify it, if both of those equal x, yes, they're inverses. But we have to show all the work to prove that they equal x. We can't just write this, because that's just making the assumption that they're inverses. It might not be. All right. You got to make sure that both of those would equal x. When you substitute g of x into x, and when you substitute f of x in for x, do they both equal just an x? Then the last page. Oh, there's 2 more problems. So you got 4 problems to practice on inverses. And then here's the last problems. Find the inverse. So you got to do this, find the inverse. Remember those 3 steps, 1, 2, 3. Change it to y equals, then swap it to be x equals, and then solve for y. Then it wants you to graph f of x, which is this, the inverse function, which we will find, and y equals x. You should have 3 lines on your graph. So let's look at, by the way, there's the study guide answers. So if I go to the answers for that, I swapped it for y equals, I changed the x and y. I moved the 1 to the other side. Then I had 2/5. So I multiplied everything by 5. That got rid of the fraction. Because whatever's on the bottom of a fraction, if you multiply everything by that, that gets rid of the fraction. So I got 5x plus 5 equals 2y, because 2/5 times 5 is 2. Then I divide everything by 2, and y equals 5/2 x plus 5/2. I can graph that because that's a linear equation. There's the y-intercept, there's the slope. There's the y-intercept, there's the slope. So I graph the green one right there. That's the original equation. The inverse is the blue one right there, and the line y equals x. And if it's all correct, you'll notice that it's a reflection. It's reflecting over that y equals x. Inverses and the function they're an inverse of will always be a reflection over y equals x. So if I do that and it doesn't look like a reflection, see, these are a reflection either too. If it doesn't look like a reflection, I've messed something up. So, all right, let me show you how to do that real quick. Here's what the test looks like. Simplify, only positive exponents, positive exponents. Some of them don't have negative exponents, but that's still in the directions. Here's simplify, simplest radical form, which we were doing that just last couple of weeks. Okay, then the next one say convert. Again, this is where it does not say simplify, so I don't have to simplify. I just have to put this in radical form and put this in exponent form. Find the inverse. Let's show your work because you got to do the 3 steps. Find the inverse of this with the 3 steps. Verify whether they are inverses. Okay. Are the inverses yes or no? You got to do that substitution, g of x and f of x and the g of x. There's another one. So 2 of those. And then there's that last problem. Find the inverse and then graph them. So when you graph, we have a graph one there. You'll find the inverse. If I want to graph that, I can go up here to the line. Pick what color line I want. Let's say I want a blue line. And I'll just pick my starting point, pick my slope. Oh, do I have it on the line? I don't think I have it on the line. See? And I can make it whatever slope I need to. Start with my y-intercept. And wherever I want to put it, I don't think that's the real slope. I just chose that. And if you get it wrong, get that eraser over here. Oop, I can take it away. I can try it again, put a new one on there. Well, maybe we're supposed to do it here. So, whatever you need to do. I think it'll let me move that. No, it's moving the whole thing when I do that. Don't do that. That'll let me move it. That'll let me make it bigger too, so I can make it bigger if I want it to go the whole graph. But I can move it wherever I need to. But if I got the wrong slope, I probably can't move it in here. I'll have to. Yeah, I guess you can adjust it some. So anyway, use the line function. You can draw it by hand if you can do a pretty decent job of it. If it looks somewhat straight, it doesn't have to be exactly perfect, but if I can tell that I was trying to go through here, see, that's if I can tell the slope is about what the slope is supposed to be, and the y-intercept's about where the y-intercept is supposed to be, I'm good with that. But if you want it to be exact, you use that line function. So, okay, so you have the study guide, which you should go through first and make sure you know how to do these things, because once you get done with the formative, you can't go back and edit that. That's a test. It gives you that one time to do that. And once you go to that last page and hit submit, now before you hit that submit in the last page, you should be able to go back and change an answer if you realize, oh, I did that wrong, right? But once you hit submit in the last page, it won't let you change anything. So that's why you have the study guide. And the study guide has the same type of problems. You don't have to work all the problems on the study guide. If you do this one and do the second one, you're like, oh, yeah, I'm not having any problem with those. I understand it. Okay, don't do any more of those. Go to the next section. Try those problems. So figure out what you need to study up on before you take the test. So that way you'll do as well as you can. See, reminders, this is the last week to enroll for virtual school for next year. So if you intend to still be a virtual student next year and you have not yet signed up for that, this is the week. get that done, because I'd love to see you back next year. For those of you that are still going to be around, I don't think there's any seniors in here, but if you're a senior, adios. But anyway, so want to remind you of that. Spring break next week. Yes, just got to get there. Make your spring break as long as possible, which means don't wait and do this on the weekend. Get this done early in the week. Get your work done and say, hey, my spring break was 9 days because I got my work done early and I took off Thursday, Friday. Right? That's what you want to do. You want to get everything in, make your spring break as long as possible. Enjoy yourself. So, all right. Any questions? All right. There's no questions. I'll let you guys go. You got a test this week. I don't want to take up much of your time. Got your study guide. Good to go. Thank you.